Ever toss an old phone and think, man, there's got to be some good stuff in there still?
Mm-hmm.
Well, get ready, because today's deep dive is about someone who takes that thought to a whole new level.
Okay.
We're talking about Dr. Edwin Hwu, Associate Professor at the Technical University of Denmark, and his lab, the MIDAS Group.
Okay.
They're turning everyday tech, stuff like, old Blu-ray players, into seriously high-performance scientific instruments.
It's wild. It's not just about saving money, though.
Right.
Which is huge, obviously. But what Dr. Hwu is really doing is he's democratizing innovation, making cutting-edge research accessible to, well, anyone, really.
Yeah.
Anywhere, no matter their budget.
See, and that's what grabbed my attention. He had this point about how making just one of anything tech-wise is just ridiculously expensive. Like, imagine if Apple was like, we're only making one iPhone ever.
Oh, right.
The price tag would be insane.
Exactly. But because they crank out iPhones by the billions, all that tech inside, it becomes crazy powerful, but also, like, shockingly cheap.
Yeah.
So that's what he's tapping into, using these readily available, really high-tech parts to make these scientific breakthroughs.
So it's like he's raiding your recycling bin, but coming up with, like, Nobel Prize-winning ideas.
Basically.
He even built a whole strobe photography system for microfluidics using a spy 10 camera and a wireless charger.
It's genius, though, when you think about it.
Okay.
Because microfluidics, it's all about manipulating these tiny, tiny amounts of liquid. And to actually see what's happening at that scale, you need a way to catch these super fast events.
Right, like a hummingbird's wings kind of speed.
Exactly. But the problem is the usual strobe photography systems, they're really complex and crazy expensive. So Dr. Who's little hacked together version, it just completely sidesteps those barriers.
Okay, but hold on a sec. For those of us who haven't been, keeping up with every microfluidics paper out there,
Sure.
what's the big deal here? What does this actually let scientists do that they couldn't before?
Oh, good question. So this kind of tech, it lets researchers actually see things like how liquids mix together in real time. But we're talking crazy fast.
Okay.
And that's huge for understanding how fluids actually behave, at a microscopic level.
Yeah.
And this has all sorts of implications.
Like what? Give me an example.
Like in drug development. For one, scientists need to study how drugs actually get into cells, right?
Makes sense.
Or in environmental science, understanding how pollutants mix in water. This is crucial stuff.
So we're not just talking about, like, taking artsy photos of water droplets here.
No. We're talking about potentially more effective drugs, faster ways to diagnose diseases, a better understanding of how pollution affects us. And it's all thanks to, well, repurposing tech that a lot of people probably have just gathering dust somewhere.
It's like finding a $20 bill in your old jeans, except instead of $20, it's a revolutionary scientific tool. And it doesn't stop at microfluidics, does it? He's using this approach with 3D printing, too, right? Another area where the costs can be, like, totally prohibitive.
Oh, absolutely.
Yeah.
And 3D printing at the microscopic level, especially this technique, 2-photon polymerization, it's amazing.
Okay.
It creates these incredibly detailed structures. I mean, we're talking building objects at the nanoscale.
Right.
Super valuable for developing tiny medical devices, creating new materials.
But that level of precision, that can't be cheap.
Oh, no, it's very pricey. 2-photon polymerization systems, those are infamous. They're incredibly slow, ridiculously expensive. Most researchers they can't even get near them.
Right.
But Dr. Hwu saw an opportunity. He took a Blu-ray player.
Wait, seriously?
Yeah, took it apart, took the fast-spinning disk drive, the precise laser it uses to read the data, and repurposed them to build a 3D printer. He calls it Bright 3D.
Hold on. He built a 3D printer from a Blu-ray player? Come on.
Yeah.
That's like
That's next level.
next NXT level.
It really is.
Okay, so what can he actually do with this thing?
Oh, man. He's doing some really cool stuff. He's printed these micro-containers, for one.
What all this for?
Targeted drug delivery.
Get out.
Yeah. It's like, imagine these tiny capsules that carry medicine directly to, the diseased cells.
Wow.
Minimize side effects, maximize effectiveness.
That's incredible.
It's amazing. And it gets even cooler.
Cooler than tiny drug-delivering robots. I'm hooked. Tell me more.
He's working on building a portable lab on a drone using this technology.
Okay, now my mind is officially blown. Wait, we can't forget about the atomic force microscope he built, right? The one that costs a fraction of what they normally go for. Didn't we say something about those costing, like, $250,000 usually?
Right, and he built his version for just a couple $1,000.
Are you serious?
Yeah. Atomic force microscopy, it's this super powerful technique. Lets scientists see and manipulate materials at the atomic level.
Yeah.
But the cost, huge barrier.
For sure.
Dr. Who's breaking that barrier
Mm-hmm.
could totally pave the way for tons more nanoscale research all over the world.
It's like something straight out of a science fiction novel. But it makes me wonder if he can do all of this with, like, off-the-shelf parts.
Yeah.
What are the big companies doing? Why aren't they developing these more affordable tools?
That's the million-dollar question, right?
Right.
Part of it might be just, market forces at play.
Okay.
Might not be a huge demand for a $2,000 atomic force microscope from a big university or a company that can afford the, $250,000 model.
So it's like a catch-22. These incredible tools could revolutionize research, but they might not get developed because the existing market is already tied to expensive equipment.
It's definitely complicated, and I don't think there's one easy answer. What's important is that, Dr. Who's work is shining a light on this whole thing.
Right.
Showing that there's another way to do it.
Yeah.
He's part of a growing movement.
Right.
You've got makers, hackers, citizen scientists,
Cool.
all challenging the status quo. They're showing that innovation can come from anywhere.
That's awesome. But I'm also curious about the bumps in the road,
Yeah.
Because repurposing consumer electronics for, like, cutting-edge science can't be all smooth sailing.
Definitely not.
It's
not always easy.
Yeah.
One of the biggest hurdles is manufacturers. They're really protective of their intellectual property,
Of course.
which makes sense. But it can be tough to find, like, the nitty-gritty specs and data sheets that Dr. Who needs to actually figure out how to repurpose these things for science.
I get it, though. I mean, the companies don't want people taking apart their products and, maybe undercutting their sales. But you think they'd be a little excited to see their tech used for, actual scientific advancement?
You would hope so, right?
Yeah.
But the reality is, it often comes down to protecting their bottom line.
Makes sense. So what does Dr. Who do then? Does he just have to reverse engineer everything himself?
A lot of times, yeah.
Wow.
Takes a ton of ingenuity, obviously, and patience.
Yeah.
A little MacGyver-like resourcefulness doesn't hurt either. He's digging through forums, collaborating with online communities. Sometimes it's just trial and error until something clicks.
That's a steep learning curve. He must feel like he's constantly playing catch-up with the latest tech.
Oh, absolutely. Which actually brings up another challenge. How crazy fast technology advances.
Okay, but how's that a bad thing?
Well, on the one hand, it's fantastic because it means there's this constant flow of new, more powerful parts becoming available for him to tinker with.
Sure, it's like a never-ending buffet of high-tech ingredients.
Right. But on the other hand, the tech he's hacking, it can become obsolete just as quickly.
Oh, right.
So just when he's mastered repurposing a Blu-ray player, a new model comes out and he's back to square one.
It must be incredibly frustrating. It's like building a house on a foundation that keeps shifting beneath you.
Yeah, it really makes you wonder about how sustainable this all is in the long run,
Right.
Can you really build something lasting, like real scientific progress, on a foundation of, constantly changing tech?
It's a big question, no doubt. And, no easy answers.
Right.
But I think Dr. Who would probably say that adaptability, that's just built into the work itself.
Okay, I see what you mean.
You have to embrace the fact that it's all impermanent, that tech is always evolving. And then you find those clever solutions within those limitations.
So it's less about building something that's meant to last forever.
Yeah.
It's more about becoming really good at, like, navigating a tech landscape that just never stops changing. Exactly. You got to be resourceful, inventive, willing to just try things out. And honestly, that's a good lesson for anyone, scientist or not.
Totally. It's that whole maker spirit, right? Looking around, seeing the potential in everyday things and not being afraid to, pop the hood and see what's inside.
100%. And that reminds me of another really important aspect of his work.
What's that?
It's just, like, deeply inspiring.
Yeah.
He's not just building cool gadgets. He's sending this message that, you don't need some $1 million lab to make a real difference in science.
He's basically saying, hey, you can do this too.
Exactly. And people are listening.
Yeah.
We're seeing more and more citizen science projects, these DIY biolabs popping up, open source hardware initiatives all over. It's awesome.
That's so cool.
People are empowered now. They can experiment, innovate, push the boundaries, no matter their background or how much money they have.
It's like he's unlocked this whole new way of doing science, one that's way more accessible, more democratic, and just way more exciting, honestly.
Couldn't agree more. It's shaking things up, challenging who gets to decide what's worth knowing, who the experts are.
Absolutely. So as we start to wrap up our deep dive here into the amazing work Dr. Hwu's doing, got to bring it back to our listeners.
Of course, yeah.
Why should they care about any of this? What are the big takeaways we want them thinking about?
Well, at the heart of it, I think it's a really powerful reminder that the coolest, most innovative ideas, they can come from anywhere. You have to be willing to look beyond the obvious, challenge what you think you know, and just get creative with those solutions. And it has to be about, making knowledge and tools available to everyone. That's how you empower people to really make a difference.
So it's bigger than just science then.
Right.
It's about changing how we think, breaking down those barriers, and honestly making a future that's more equal and innovative for everyone.
Exactly. And, it starts with one simple question.
That's that.
What if?
I like it.
What if we could make scientific research something anyone could be a part of? What if it didn't cost a fortune? What if that next big breakthrough came not from some, fancy lab, but from a garage, from someone tinkering with old electronics?
Now, that's something to think about. It makes you realize the future of science, the future of innovation, might be closer than we think. And a lot more accessible, too. And on that note, we want to hear from YU. What everyday gadgets do you think can be repurposed for some crazy science project? Hit us up on social media, let us know your ideas, and don't forget to check out the show notes for links to Dr. Hwu's work, including those awesome how-to guides he's put together for building your own scientific instruments. You never know, you might just be the next DIY science hero. Thanks for joining us for another deep dive. Until next time, keep those minds curious and those hacking spirits high.